Oh hey there, SciFest All Access viewers, and welcome to the virtual STEM stage. I'm the Hip Hop MD, and this is Hip Hop Science. I'm here relaxing on my patio in beautiful Los Angeles, California on an amazing 95-degree summer day, sipping some H20, which got me thinking, water, this sustainable resource that gives us life that covers 70% of the earth and makes up the bodies of every living organism. It's pretty underrated. I mean, when you break it down, like literally, water, it's pretty dope. So we use water for a plethora of different things. We of course drink water, whether from the tap or bottled from your local supermarket or convenience store. We swim in water at swimming pools or in the deep blue sea. We clean with water, whether for our hands, 20 little yachties, 19 little yachties, 18 little yachties, or to wash our cars. We even waste water. Like, literally. And wildlife thrives in watered habitats such as lakes or streams. But no matter what we use water for, the most important thing is that this water must be clean, or as DJ Mustard and the Migos say, pure.
Ice chain, pure water.
So what actually goes into making our water clean, or as we scientists like to call it, water quality? In order to truly understand that, we first need to know how our water gets dirty in the first place. This means we need to understand the concept of solubility. We deal with soluble substances every day. Something is considered soluble when a solid substance known as a solute dissolves inside a liquid substance known as a solvent. This dissolving process changes the chemistry of the solution because particles are now broken down or combined to form new elements. You can actually test the solubility of different substances yourselves at home with a few simple household items. Using some glass jars, cups, or bowls, you can figure out what elements you have at home that are soluble. Let's look at 4 common solutes: salt, sugar, pepper, flour, and of course our solvent, water. If you add a teaspoon of each solute into a jar of our solvent and stir, you can clearly see how the process of dissolving happens. Salt, sugar, and flour are all soluble, which we can see by how they react within water, forming salt water, sugary water, or juice if combined with the sugars of a fruit, and dough, which we can eventually use to make breads, pizzas, or cookies. The dissolving of a solute in water can even occur much quicker if our solvent is heated up. Try mixing your same solutes, but this time in boiling hot water, and see how much quicker they dissolve this time around. Higher temperatures cause water molecules to move around extremely fast. This increased speed accelerates the mixture of the solutes, which we can see in solutions like coffee or tea. Pepper, on the other hand, is not soluble, and regardless of how cold or hot your solvent is, will never completely mix to form a solution. Think of pepper as Nicki Minaj trying to be the 4th member of Destiny's Child. So now that we know solubility, how does this apply to the quality of water we use every day? Well, soluble and insoluble substances exist all around us in every environment. Certain insoluble substances we can see, such as dirt and debris particles on the water's surface, but many soluble substances are unknown and can come from multiple different sources. These can include runoff of chemical fertilizers from farmlands into freshwater streams, or even wastewater or other toxic byproducts into our oceans. In order to ensure the protection of critical habitats, such as oceans or rivers, the wastewater we produce as humans must be treated before being released into our environment. This includes drainage from our sinks, bathtubs, dishwashers, washing machines, and yes, of course, our toilets. Stormwater or rainwater must also be treated because harmful substances such as oils, gas, and other chemicals can collect from our roads, parking lots, and homes and make their way into fragile ecosystems. Water treatment plants are designed to process water for different uses by using very similar methods. Wastewater treatment is a multi-step process that includes screening of the wastewater to remove large items like wood, rocks, or even dead animals. Pumping of the water, which uses gravity to move the water through the treatment process, aeration, which pumps oxygen through the water to help separate organic material. Sludge and scum removal, where heavy and light organic materials are filtered from the top and bottom of the water. And then an antibacterial process, where chemicals like chlorine are added to kill off any remaining bacteria. The resulting treated water, known as effluent, is then deposited into man-made reservoirs like this, where it can now be transported cleanly into rivers or the ocean. Drinking water goes through a very similar and extensive treatment process as well. Safe drinking water is first sourced from either a surface water source, such as a lake or watershed, or a groundwater source, such as a well. It then goes through a coagulation and flocculation stage, where positively charged chemicals are added to neutralize negatively charged particles. A settling process known as sedimentation then separates heavier particles, and a filtration process using compositions of sand, gravel, and charcoal helps remove dissolved particles. The water is then disinfected with chemicals such as chlorine before being transported to businesses and homes, into your water pipes, and coming out dripping through your faucets.
Came through drip, drip, drip. Came through drip.
The filtration process of water is incredibly important, and it's what ensures us of having safe water we can drink and cook with. But you don't need to go to a multi-million-dollar treatment facility to learn how to filter clean water. You can filter clean water yourself at home.
Did I say home? Well, if you're a merman or mermaid, the beach might be home to you, which is actually perfect because you'll need a little bit of sand, some gravel, maybe I do need to go home.
Okay, cool. All right, some gravel, a few small rocks, a coffee filter, and either some cotton balls or pads. You'll also need a plastic container, scissors, rubber band, and a small basin. Cut the bottom off your plastic container. This is going to be our main filtration unit. Tie a coffee filter to the bottom of your container with your rubber band. Add cotton pads or cotton balls to create a couple inch thick layer. Next, add a couple inches of your sand, add a couple inches of gravel, and if you want, repeat these layers again. At the top, add your medium-sized rocks, and then place your bottle over a jar or other clear cup. Fill your basin with some regular tap water. You can dirty it up using whatever random items you could think of. Soil, soap, bathroom cleansers, cooking oil, bird poo. Okay, maybe not bird poo, but get creative. Your dirty, disgusting basin is similar to wastewater that's released from a home's or storm drain runoff from the streets. Pour this mixture into your filtration system and observe the water that's released at the bottom. You should notice at least a slightly different looking substance, hopefully cleaner and clearer than what you originally put in. A result that will give a whole new meaning to no filter. Now, this filtered water is by no means drinking water quality, so don't go sipping. Nor is it necessarily safe to be released back into the environment, but this process represents much of the same processes our drinking water and wastewater go through to be properly treated. However, if you grew up like I did in a small village in the West African country of Cameroon, available clean water sources for you might be direct rainfall collected in buckets or irrigated water carried straight from a nearby lake or stream. In some countries, you might even have to travel miles in search of usable groundwater, and even then still be susceptible to contaminants and other potential biological diseases. Access to clean water is a very real and dangerous problem that threatens millions of people all across the globe. So with water quality being such an issue, how exactly do we determine if what we're drinking is actually clean water? I mean, even the water from the stream looks lush and refreshing. The EPA, or Environmental Protection Agency, here in the US, sets standards for drinking water quality. This is a fundamental requirement from the Safe Drinking Water Act that's intended to ensure safe drinking water for the entire public. These laws are enforced by individual state health agencies, and although the standards can be strict, many situations involving inadequate safe water still occur in communities in America. The city of Flint, Michigan was one such community, where in 2014, when transitioning to a new water source, officials failed to apply corrosion inhibitors to the water, resulting in lead contamination that exposed hundreds of thousands of residents to dangerously high lead levels. So if you're now wondering, how do I test the levels of my own water or water around me to make sure it's safe?
It ain't safe, it ain't safe, it ain't safe, it ain't safe.
The answer is a water quality test. Simple home tests like these can tell you some important chemical facts about the water you're dealing with. These tests can vary. They give data about key elements that affect us as humans directly. A pH test or power of hydrogen test tells us the acidity or basicity of the water. Water that's more acidic falls on a lower pH range, while water that's more base is higher on the scale. Pure, clean drinking water falls right in the middle of the scale with a pH level of 7 or neutral. Nitrate and nitrite levels in water are a clear detection of possible fertilizer or waste contamination. Nitrates are soluble compounds and are commonly found in agricultural fertilizers or as byproducts from human waste. These fertilizers can seep through soil into groundwater or surface water, and if not treated properly, can end up in your tap or bottled water. As we mentioned previously when discussing water treatment, chlorine is used in the last stages of the treatment process to disinfect the water and make it suitable for consumption or release. The most clear example of this is in swimming pools, where chlorine levels are much higher to help prevent the spread of bacteria and viruses to swimmers. When testing water you intend to drink, these numbers are incredibly important to make sure your water is safe for consumption and completely free of any chemicals. So now that we know the solubility of chemicals that affect water, the filtering and treatment process the water goes through to make it suitable for drinking or waste, and how to truly identify what fresh and clean water is, we now have the tools and knowledge to not only determine various water quality levels in any state or country you live, but also to see just how dope water really is. So next time you're lounging on a hot summer day, gulping down your favorite water of choice, think about everything that went into ensuring, or maybe not ensuring, its true quality. I'm the Hip Hop MD. This is Hip Hop Science, reminding you that curiosity is nature's PhD. Never stop asking. Cheers.